Do I have your permission to record these lectures from today moving forward?
Yes.
Yeah.
Very good.
Yes.
Awesome. Thank you, everybody. All right, so everyone, we are looking at quadratic equations or quadratic functions. Now, when we talk about a quadratic equation or quadratic function, guys, we're looking at equations of the form y is equal to, sometimes my pen acts up, so be patient with me, guys. ax squared plus bx plus c. Now, this is just a quadratic equation. In order for it to become a function, guys, we must replace the y variable with f of x. So by replacing it with the f of x, you now have a quadratic function, guys. You see that? Equation is the first one, function is the second one, because we're using that f of x notation. Now, guys, these are called second degree equations or functions. Second degree equations or functions. Now, why do we call it a second degree function or equation, guys? Here's why we call it a second degree equation or function, because the highest power on x is 2. That's the reason why. So guys, because it's a quadratic function, it's a second degree function, we are going to look at what that means. What does that mean, guys? Okay, here's what it means. It means, guys, when you solve these, okay, you can find at most 2 solutions. Now, guys, listen to this. You have to know the vocabulary when you are on these tests. You have to know the vocabulary. Why do you need to know the vocabulary? Because sometimes, guys, these questions want you to know what the words mean, okay? So when you solve these quadratic equations, guys, at the most, you will find 2 solutions, okay? The 2 solutions, guys, other terms that mean solutions: zeros, roots, and then, guys, a famous one are the x-intercepts, So whenever they talk about zeros, roots, x-intercepts, solutions, all they are asking for are the answers to an equation. In this case, guys, a quadratic equation. All right. So now, additionally, guys, in order for you to have a quadratic equation or a quadratic function, you must have the x squared term. If you don't have the x squared term, guys, it cannot be a quadratic. So in other words, if the a value was 0, okay, and you multiply anything by 0, what do you get? You get 0. So if a was 0, you would no longer have the x squared term, so it would not be a quadratic. So therefore, guys, a cannot be 0. Anything else can be 0, but a cannot be 0. Now, let me give you some more terms, guys. You ready? Here we go. I hope you guys are taking some notes. This is good stuff, okay? This is called the quadratic term, okay? Quadratic term. Bx is called the linear term. Why is it a linear term, guys? Because the power on x is 1. In order for you to have a linear equation, the power or the degree on the x term has to be 1. Next, guys, C. C, listen up, guys, is called the constant term, okay? And you know what, on a side note, let me say this because you guys took the PSAT back in October. If they're talking about a constant, guys, most of the time it's C, but every once in a while they will use the letter K for constant, okay? And then one last variable I need to mention to you guys, that is A. A, the number in front of x squared, is also referred to as the leading coefficient. Do you guys understand what a coefficient is, or do you need me to go over that? Okay, raise your hand if you don't understand what a coefficient is. Raise your hand if you don't understand what a coefficient is. Nobody's raising a hand, so you guys are good. Awesome. So guys, let me recap everything I just said. And remember, this is vocabulary. It's good to know the vocabulary. So a quadratic equation is a second-degree equation. So, oh, look at Isabella. Come on in, Isabella, okay? A quadratic equation, guys, is a second-degree equation. You can find at most 2 solutions for a quadratic equation, okay? Now, in order to have a quadratic, you must have an x squared term, meaning a cannot equal to 0. Your a must be anything else but 0, okay? Next, when you're looking at quadratic equation or quadratic function, you're looking at the form, guys. Ax squared is called a quadratic term because that's the term that has the x squared. It has the power of 2. Bx is your linear term. C is your constant term. And then, guys, here's another one. A, the number in front of x squared, also referred to as the coefficient. We call that the leading coefficient. And the reason we call it the leading coefficient is because it's the number in front of the term with the highest power. All right, so now I know what some of you are saying. Well, Miss Alcira, wait a minute. I'm not seeing anything that we've done in class yet. So where's the stuff we're doing in class, Miss Alcira? Okay, guys, here it is. Now, pay attention, guys. I'm gonna go through a lot with you, okay? So I'm gonna give you a very basic quadratic function. F of x, sugar plums, is equal to x squared plus, oh, I'm gonna make this super easy, guys. Let's do 3x plus 2. I mean, yeah, let's do plus 2. That's the quadratic function. All right. So guys, here's the first question for you. Let's see how much you guys know. We're going to graph this. We're going to graph it, okay? In order to graph this, we need the vertex. The vertex is a point, guys, a coordinate point. We need the y-intercept, all right? That's another point on the graph. We need the axis or the line of symmetry. Now, this one here, like I said, it's a line. The axis of symmetry or the line of symmetry. All right, guys. So here's the first question for you guys. Ooh, guys, I just realized something. That 3 is not going to work out nicely, so I might have to change it there, okay? I might have to change it just slightly, okay? All right, guys, first question. If I were to graph this one, is the graph of this parabola going to open up or is it going to open down? You guys drop it in the chat. Let me know. Is it going to open up or is it going to open down? So that's the first thing. Everybody should know that. Here's a quadratic function. Is the graph going to open up or is it going to open down? Drop it in the chat, guys. Come on, guys, drop it in the chat. Type it in there. Is it going to open up or is it going to open down? Okay, Kylie's giving me up with a question mark. So you're not sure, Kylie. I see you. Okay, Keenan is like, yes, it's up. Okay, look at Jaden. Jaden says up, okay? Now, Sugar Plums, I'm gonna have a little conversation with you too. Oh, look at you, okay? Okay, okay, I'm not gonna pronounce your name yet, Sugar Plum. All right, anybody else? No? Okay, guys. So, my Sugar Plum here, okay, my first Sugar Plum who answered, Kylie, listen, Sugar Plum, one of the things you need to do when you say your answers, even if you say, if it's wrong, say it with conviction. Okay, yes, ma'am, I will just call you Sugar Plum. Okay, listen, Sugar Plums, especially my young ladies, listen to me. What I find out with most of my young ladies is that sometimes when you give the answers, you don't say them with conviction. as in you believe in your answers. You're not sure, you don't trust your answer. Say it with conviction. The guys, when they come in with their answers, it's like up, okay? There's no question mark. There's no I think. Most of my young ladies, when they're answering questions, it's like, I think, I'm not sure, but I think. Listen, ladies, even if it's wrong, just say the answer, okay? Whether it's wrong or not, just say it with conviction. Say it like you know it's the correct answer, even if it's wrong, guys. Just say it, okay? Say it proudly, okay? Now, sugar plums. All right, let's go ahead and keep going. Perfect. How do we know if, okay, a graph is going to open up or down? We'll look at x squared, guys. If x squared is positive, okay, I'm making it very basic for you guys. Positive x squared, it's going to open up. Negative x squared, it's going to open down, guys. By the way, I didn't even mention this to you guys. Do you guys know what the graph of a quadratic is called? What is the graph of a quadratic called, guys? Drop it in the chat. What is the graph of a quadratic called? I love it. All right, Miss Kylie. Love it. Come on, guys. You got this. What's the graph of a quadratic called? Come on, Sugar Plum. Really? Nobody? Drop it in the chat. Somebody. And oh, Isabella got it. Okay. Oh, okay, Kylie. I see you, Kylie. By the way, the chat is on private. All of these answers are just coming to me. Nobody else is seeing them. All right, Ariana, I see you. Ariana O, I see you. Okay. Very good, Sugar Plums. All right. So listen, guys. The graph of a quadratic is called a parabola. Parabola. Okay, parabola. Oh yeah. It's a parabola, guys. All right. It looks like a letter U when it's opening up. When it's opening down, it looks like a letter N. Okay. It's a parabola. All right. So guys, that's another term for you. The graph of a quadratic is a parabola. Either the parabola is going to open up or it's going to open down. Now, I put positive x squared to open up, negative x squared to open down. But here's another way they would say it to you guys. If A is greater than 0, that still means it's positive, guys. It opens up. If A is less than 0, that still means it's negative, guys, okay? It means the same thing as positive x squared, negative x squared, okay? You just got to know the terminology. Okay, so good. I'm glad you guys know how to determine if the parabola is going to open up or down. What do you look at? You look at x squared, guys. If x squared is positive, opens up. If x squared is negative, it opens down. Right here, guys. That's the first thing. Okay. The next easiest part of this, guys, is the Y-intercept. All right, Sugar Plums. All right, Sugar Plums. You ready for this? The Y-intercept is where, and you can do this for any graphs, guys. This is where a graph intersects the y-axis. Now, in order to find it, guys, what you do is this. You plug in 0 for x. So let x equal to 0. Let x equal to 0. Solve for y. Okay? Now, guys, I'm making it as easy as possible for you. So essentially, guys, when you go into the quadratic equation or function and you're trying to find the y-intercept, you go and find all the x's, plug in 0 for them. Now remember, guys, f of x and y are exactly the same thing. F of x and y are exactly the same thing. So if you don't like using f of x, you can use y instead. All right, Sugar Plums, you ready? Here we go. So if I take 0, guys, and go back into the quadratic equation and I plug in 0, guys, look up. If you're writing, stop writing and look up. If I plug in 0 in here, this is going to cancel out. If I plug in 0 in here, this is going to cancel out. What do I have left over, guys? Tell me. Type it in the chat. What do I have left over? Drop it in the chat. What do you see is left over out of that equation? What's left over? Come on, guys. Go for it. Be proud of your answer, guys. Be confident in your answer. All right, Miss Ariana. I see you, Miss Ariana. Okay, I see you, Miss Kylie. Okay, now, Miss Kylie, I like the way you put that notation in there. Very nice. Very good. Okay, so guys, listen, what you have left over, once you plug in 0, now you notice I'm scratching all those x terms out, because when you plug in 0, guys, the terms basically disappear. They cancel out because 0 times anything is 0. Now I'm going to erase all of that, okay? So there we go. So Miss Kylie wrote it down like this for me, guys. Let me show you. Miss Kylie said, hold on a second, let me write it down. I'm gonna be finished in a minute, okay? All right, so Miss Kylie said this, guys. She's like, okay, this is what my answer is going to look like. F of x equals to 0. You're absolutely right, Miss Kylie, okay? Now remember, Miss Kylie, f of x is the same thing as y. Oops, Shazam. Miss Kylie did not write that, guys. I wrote the wrong thing, okay? It's supposed to be 2, positive 2. There we go. So Miss Kylie, y is the same thing as f of x, so there you go. Y equals to 2. Now, the y-intercept, guys, is a coordinate point. So when you are looking at the point for the y-intercept, guys, it's y equals to 2 on the y-axis. But as a point, guys, it's going to be 0 for x and 2 for y. Now, why is that, Sugar Plums? Look, we plugged in 0 for x. And when we plugged in the 0, we found out y is equal to 2. Guys, remember, when you have a coordinate point, it's always alphabetically x comes before y, Sugar Plums. Alphabetically, x comes before y. All right, everybody. So raise your hand if you did not understand how to find the y-intercept. And let me go ahead and recap. First thing we did, guys, we determined whether the graph was going to open up or down. What determines that? X squared. X squared is positive, so it's going to open up. The second thing we found was the y-intercept. How do we find the y-intercept? We plug in 0 for every single x in that equation, and we found the y-intercept. Okay, how you guys doing? Okay. All right. One person answered. Jaden said, I'm good. Okay. How about the rest of you? It makes more sense. Oh, Bridget, girl, I'm glad it's making, what? Okay, okay. Look at Kylie. Kylie's like, good. Okay. Like Kylie's like, I get this. I'm starting to get it. Okay. And Miss Bridget is like, it makes more sense to me now. That's awesome. By the way, guys, if it's making more sense to you, you know our friends who are supposed to be in here, but they're not in here, please invite them to come in. I love having lots and lots of students in my classes. Yeah, seriously. Okay, perfect, guys. Okay, so we're going to take it to the next step, okay? Next step, because we're approaching 6 o'clock, okay? We might have to postpone this video because do you guys mind if I go a little bit past 6 o'clock? Because I feel like I might need to go past 6 o'clock. Because I don't like rushing, guys, when I'm teaching. Seriously, I hate rushing when I'm teaching, okay? Okay, you guys are not saying anything, so you want to get out at 6 o'clock. It's okay. All right, guys. All right, very good. All right, very good. So, guys, here's a big one, okay? The biggest part of these quadratics, guys, when you're graphing them, is the vertex. The vertex is what you call the turning points, okay? The turning point, AKA, okay? I'm gonna make this very simple for you guys. That's the hump, Humpty Dump, okay? The hump in the graph, okay? Or the peak in the graph, or the valley in the graph. So what in the world is Miss Officer talking about? It's a parabola, guys. When it's opening up, it looks like this, okay? So when you're graphing, guys, you always go from left to right, just like you're reading a book. You're going from left to right. So I'm starting on my left over here, guys, and I'm moving down. What happens, guys? I'm going to take a turn. There's my turn. And then the graph goes in the opposite direction, guys. You see that? Okay. That's a parabola. So where's the hump? Where's the turning point? The turning point is right there. And that's your vertex coordinate. Okay. Now, what if it's opening down? Okay, guys, let's look. I'm starting on the left and I'm going up, up, up. And at some point, I'm going to have to turn. Did you see that turn? That turn right there is the vertex, sugar plums, and goes in the opposite direction. Shazam. Okay. That's the vertex, guys. Now, the vertex, sugar plums, is a turning point. Let me see here. Somebody's sending me a little message on Teams. Okay. I didn't sign for tutoring. Okay, well, somebody added you on there, sugar plum. Okay. But I can't answer it now because I'm busy teaching. Okay, guys, listen. The vertex is the most important point on the graph of a quadratic, guys, okay? Now, they use letters to represent the point. Remember, it's a point. They use letters for it. Don't get bothered by the letters. They're just letters replacing X and Y, guys. We call it HK. That's still the same thing, guys, X comma Y, okay? They're just using different letters. And there's a reason why they're using those letters. That's okay. Do not worry much about it. Okay, guys. So to find the vertex, guys, okay? The vertex is really, you kind of lit. She's trying to help us now. Oh my God, look at you guys. You guys are so cute. Okay. All right, guys, listen. The vertex is very, very important when it comes to these graphs. And one of the reasons why I said I'm not liking this equation that much is because, guys, this value right here, the 3, is critical in finding the vertex. All right, guys. So listen, here's how we find the vertex. I might have to change a number here and there just to make sure it works out. Okay, guys? I'm going to have to change a number here and there. All right. So, guys, I want you to notice this, okay? Listen to me. It is a coordinate point. This form of the quadratic equation, we refer to it as the general form. When it is in this form, sugar plums, when it's in this form, listen, when we're finding the vertex has an x coordinate. So to find the x value of the vertex, sugar plums, you're going to do the formula. Listen, a formula. The formula is negative b, the opposite of b. I like saying the opposite of b, so I can remember to change b. The opposite of b over 2 times the value of a. Miss Alcira, what in the world are you talking about this formula? What is this formula right there, Miss Alcira? Sugar plum, these letters are from the equation. Remember we talked about A, B, and C earlier? Well, here they are again, sugar plum. So now we're going to use them to find the x value of the vertex. Now remember, the vertex has an x, it has a y. So we're gonna find the x first. Okay, guys, so here we go. To find the x, by the way, guys, I'm gonna do a little change, just slightly. Bear with me, guys. I'm gonna change this 3. I am going to also change the 2, okay? Basically, I'm gonna swap them, guys. I'm gonna swap them, okay? I'm gonna swap them. And let me tell you why I'm swapping them. Because I want us to deal with beautiful numbers, okay? I don't want us to deal with fractions and decimals that's gonna confuse you right now. But now, I just want you to get the basics, okay? So I'm gonna put a positive 2 here. Hold on a second, guys. Let me fix that. Positive 2 right there. Okay, I'm just swapping. I'm just swapping a little bit. And I am going to make this. Oh, Shazam, come on. Ooh, oh, wait a minute. Back up now. Okay, that's not what I wanted to do. Okay, now I'm good, guys. Okay, so, oops, nope, that's still wrong. Okay, wait a minute, guys. Be patient with me. I'm still teaching you. I'm still teaching you. Right there, guys. That's nicer. All right. Now, why did I do that, guys? Because I want to make sure I end up with beautiful numbers. Okay, guys. A is the number in front of x squared. So there's no number here. It's understood to be 1. B is the number in front of x. That's 2. C is the constant term. That's -3. So guys, if we go into our little formula here, a little formula right here. A is equal to 1, B is equal to 2. We're going to plug everything in. So guys, let's do it. All right, so you're looking, X equals to the opposite of B. Now B is positive 2, so if we do the opposite, we get negative 2. Over 2 times whatever the value of A is. What's the value of A? 1. Now guys, you're going to work it out. So you get negative 2 divided, I'm running out of room here, Shazam. Guys, I'm running out of room on my tablet. Let me go ahead and squeeze it like over here, okay? I'm gonna squeeze it to the side over here, guys. Okay, I'm squeezing to the side. So I get negative 2 over positive 2, everybody. Negative 2 divided by 2 is negative 1. That's the X value of the vertex. So for this graph, guys, when we're graphing it, the X value of the vertex is going to be at negative 1. Now, let me just say this one more time, sugar plums. The vertex is a coordinate point. It's a coordinate point. It has to have an X, it has to have a Y. So what we just found was just the X value of the vertex. So our vertex is going to have an X value of negative 1. Now, we need to find the Y value. All right, Miss Kylie, look, f of X is the same thing as Y, Miss Kylie. So to find the Y value of the vertex, guys, here's what we're going to do. We're going to plug it in, plug it in, plug it in. We're going to take that negative 1, which is X, and we're going to go into the equation, guys, and we're going to plug it in for X. Plug it in, plug it in, plug it in, sugar plums. Plug it in, plug it in. Did I say plug it in? Plug it in, okay? I'm going to plug it in, guys. And then we're going to calculate the value of Y. So negative 1 squared is 1. 2 times negative 1 is negative 2. Oh, there's supposed to be a negative 2 here, guys. Minus 3. There's a minus here somewhere. My pen is not cooperating with me. And then we work it out, we get negative 4. So guys, what did I just find? The Y value of the vertex. Okay, Miss Alcer is going to pause right here because I don't want to make sure, I don't want to lose anybody, okay? I want to make sure everybody's with me, okay? So Miss Alcer is kind of like pausing just in case you have a question, Sugar Plum. Feel free to ask your questions. I love questions. I don't know if you guys have siblings that went through Centennial that had me as a teacher, or perhaps you had your parents who had me at the college or something like that, or you had your siblings that had me at the college, but I love questions. Ask questions, guys. Ask me lots and lots of questions. So if you're lost right now, talk to me. If you have no clue what you're doing right now, what in the world am I doing? What am I talking about? Talk to me, guys. Ask me anything. Anything. You sure, Sugar Plums? Okay, I hear you. Miss Alcira, it's after 6 o'clock, Miss Alcira. Let's get this over with. Okay, we're going to get it over with. Let's wrap it up, guys. Let's wrap it up. Okay, we're almost there, guys. Okay, let me go ahead and clear out the entire thing so I can make it faster. Okay, guys, so let's recap. Remember, we're going to be graphing this, okay? X squared, it was plus 2x minus 3 because I changed it up slightly. We know the graph is opening up. We did find a y-intercept, but that was for the previous problem, guys. So the y-intercept. Oh my God, you guys tell me, what's the y-intercept value now? Drop it in the chat, guys. What's the y-intercept? Shazam, since I changed the equation, it changes the y-intercept. You guys tell me the y-intercept. Drop it in the chat, guys. Drop it in the chat. Drop it in the chat, Sugar Plums. Oh, I'm not seeing too many of you dropping it in the chat now. Come on, Sugar Plum. How do we find the y-intercept again? We replace all the x's with 0. We plug in 0 for all the x's and work it out. Come on, guys. Come on. Oh, come on. I know you guys got this. Even if it's wrong, guys, just put it in the chat. Oh, Miss Kylie. Look at you, Miss Kylie. Okay, I see you, Miss Kylie. Now, Miss Kylie, remember that 0 is supposed to go in for x, okay, for every x in that equation. And then you find the answer. Come on. Oh, Miss Kylie, you almost got it. Almost got it, Miss Kylie. Oh, Miss Kylie, you got it. Miss Kylie, you got it. Okay, I need somebody else to tell me. Okay, Miss Kylie got it. Anybody else? Isabella, Jaden, come on now. Come on, Bridget, come on now. Come on, guys, drop an answer in the chat. Come on, you can do this. Remember, guys, think about what I did earlier to find the y-intercept. When you plug in that 0 for x, what happens to all the x terms? And once that happens, what are you left with? Oh, come on, guys, don't disappoint Miss Alcira like that. Oh, come on, I know you guys got it. I know you guys got it. I'm not going to give up on you. Okay, Jaden, I see you, Jaden. Come on. And don't just guess, guys. There's a work, there's a process involved there. Okay, guys, just to recap. You plug in 0 for every x. You plug in 0 in here, this cancels out. You plug in 0 in here, this cancels out. What are you left with, sweetie pie? Oh, Keenan, I see you, Keenan Bird. And you're left with the C value. Oh, Isabella, I love it, Isabella. But what is the C value, Isabella? All right, Miss Thing. Now you guys got it? Yes, the C value, you left with the C value. So guys, when we're finding the y-intercept, you could actually say this. It is 0, comma C. Okay, 0, comma C. All right, as a coordinate point. Very good, sugar plums. See, you guys are learning. You guys are learning. I'm telling you, you guys are learning. Okay, so let's keep learning, guys. So we got our y-intercept. The y-intercept is -3 on this one. 0, comma -3. Now, guys, here's the last thing I'm going to tell you, and then we're going to graph. I know that horrible axis or line of symmetry, guys. That line of symmetry, listen to this, guys, and you're going to get this, okay? Here's your parabola. This is your vertex. The line of symmetry, sugar plums. Listen, it goes straight through the middle of the graph, intersects the graph at the vertex. It's a vertical line. When you draw a vertical line, guys, which axis is it going to intersect? Is it going to intersect the x-axis or the y-axis? Drop it in the chat for me, or you can turn on your mic and tell me. When you draw that vertical line, guys, is a vertical line going to intersect the x-axis or the y-axis, guys? Somebody, anybody, come on, guys, you can do this. It's a straight up and down line. If it's up and down, which axis is it going to touch? Very good, sugar plum. Shanib, okay. Kylie, I see you. Very good, ladies. Very good. And I love it how you're saying it with confidence, Keenan. Look at Keenan. Keenan is like, the x-axis, okay. You guys are absolutely right. So guys, listen to this, because it's touching the x-axis, it's intersecting the x-axis, it's going to be an equation. And the equation is going to be x equals to wherever the graph intersects the x-axis at. So now, guys, here's the big question. Here's the big question for you guys. Since it's going straight through the middle of the graph and it's intersecting the graph at the vertex, guys, listen to this. We already have the answer. Oh, let me say that again. We already have the answer. Why? Because we already found it, guys. It's in another part of the problem. What part of the problem is it in? It's a part of the vertex. I mean, it intersected the graph at the vertex. That's your line of symmetry. So guys, x equals to, listen to this, sugar plums, whatever the x value of the vertex is. What's the x value of the vertex? -1. Yep. There's your axis of symmetry, line of symmetry, guys. And just like that, you have your equation, okay? So guys, here's the last part. Miss Alcira is going to graph this for you so I could show you the graphing. I forgot which one of my sugar plums said, you know, I really don't get the graphing. The graphing just gets to me. I just never got the graphing. What's up with the graphing? All right, guys, so you ready for this? Pay attention, sugar plums, okay? So you have all your components. We're ready to go ahead and graph. The first thing you need to graph, guys, number 1, the vertex. -1, x is -1 right there, guys, right there on the left side, okay? And then from x equals to -1, you're gonna travel down 4 units, -4. 1, 2, 3, 4. That's the vertex coordinate. Are you guys okay with that? That's the vertex. Now, guys, here's the next part. The y-intercept. We're going to graph that second. The y-intercept is at 0, -3. Remember, it's a y-intercept. So all you do is go straight to the y-axis. This is your y-axis right there. That's your x-axis. So go to the y-axis, find where y is -3. Bam. That's it. I went to the y-axis. This is -1, that's -2, that's -3, that's -4. I find where y is -3, I plot my point. Okay, guys, we're almost there. Here it is. Here's the line of symmetry, guys. We're gonna sketch out the line of symmetry. I'm dotting it out because it's not supposed to be part of the graph. That's the line of symmetry. Now, guys, here's the key to graphing a quadratic, okay? You ready? You've got your y-intercept right here. We're going to reflect the line of, the y-intercept across the line of symmetry. This point right here is 1 step away from the line of symmetry, guys, on the right side. So we're gonna go 1 unit away on the left side from the line of symmetry and plot the reflection of the y-intercept. Let me do that again, student part, because I don't want to confuse you. One more time. Here's your y-intercept. It's 1 unit away from the line of symmetry on the right side. So we're gonna go 1 unit away on the left side of the line of symmetry. Notice how they're directly across each other right there, because these graphs are symmetrical. What you see on the left is what you see on the right. So guys, we have 3 beautiful points and we're ready to sketch the graph of the quadratic. So here it is, sugar plums. And there you go, sugar plums. There you are, sugar plums. Yes, sugar plum. The left side reflects the right side and the right side reflects the left side. Now, Kylie, let me tell you, here's how you're going to remember symmetry, okay? Symmetry is about balance, sweetie pie. Look at your face, Kylie. If you draw a straight line down the middle of your face, Kylie, what you see on the left is what you see on the right. So your faces, okay? They're symmetrical because what you see on the left is what you see on the right. And guys, here's the best part about symmetry. Symmetry is about balance. So beautiful people have symmetrical faces, like Miss Alcia's face. Isn't my face symmetrical? That's all of you guys, okay? All of your faces are beautiful because they are symmetrical. Hello, sugar plum. They're symmetrical. That's going to help you remember symmetry and reflection. What you see on the left is what you see on the right, guys. You have your nose, you have your lips, you have your eyes, okay? They're reflecting each other. Your nose, one side is reflecting the other side. Same thing with your lips. One side is reflecting your ears, your eyebrows. Shazam, shazam. Okay, guys. See, I get so excited about teaching now. I just get too excited, okay? Good. I'm glad it makes sense to you, sweetie pie. Now, okay, because it's after 6 o'clock already, guys. It's already 6:15. One last thing. Oh my God, okay, you're killing me. You're killing me, sugar plum. She's like, oh my God, Kylie, we'll pretend it's your face before you did that, okay, Kylie? I love it, I love it. That's a good point you make there, Kylie. Very good point. Okay, one last thing, guys. At the vertex, sugar plums, the vertex, the lowest point on the graph, that's the lowest the graph will ever get. At the vertex, you have a minimum value, guys. That's the minimum, okay? So what is the minimum? The minimum is the y value at the vertex. All right, you guys tell me the y value at the vertex. What's the y value at the vertex, guys? The minimum is the y value at the vertex. The minimum is the y value at the vertex. What's the y value at the vertex, guys? The y value, sugar plum. Now, come on, Kylie. You want to roll, girl? Keep it going. Wait, yes, I'm waiting, Kylie. You tell me. What's the what? Miss Kylie, why didn't you just say that at first, okay? Guys, the minimum, the maximum is always the y value at the vertex, okay? So in this case, the vertex, the y coordinate of the vertex or the y component of the vertex, -3, I'm so, Kylie, no. Look at the vertex, Kylie. Here's your vertex, Kylie, right there. What's the y value at the vertex, Kylie? What's the y value? Right there. You see that? Okay, on the graph, Kylie, count it out. Well, -1, -2, -3, -4. That's the y value of the vertex. So the minimum is at -4, Kylie, okay? Now, Kylie, one last thing. Yes, I know you did. I said you're right. I said you should have said that first. Yes, you're right. Absolutely, Sugar Plum. Kylie, you got this, girl. You got this, okay? Now, if it was opening down, the maximum would be up here. And what would be the maximum value? Whatever the y value is at the vertex, that would be your max. And guys, just like that, I am done with you, Sugar Plum.